thank you, Jeff, for joining us today. For everybody else, we have Jeff Beeden from Engineering Driven Design with us today, mechanical, electrical, plumbing, and engineer extraordinaire. That teams up a lot with SSP Architects. So, Jeff, why don't you tell us a little bit about your background?
Oh, well, thanks for having me, Marcus. I've been in the mechanical, electrical, plumbing, and fire protection engineering industry for 20 years. Started off as an intern and worked my way up through different companies till I started my own firm 6 years ago. And we've been doing all sorts of commercial and industrial projects in northern New Jersey, New York, and surrounding areas to support different types of clients. We've got a pretty broad portfolio where we do work in schools, but we also do work in labs. We do work in flavor and fragrance production plants. So it keeps things interesting.
Yeah. Well, today we're going to focus in on, mechanical systems, not just in the COVID and pandemic world that we're dealing with right now, but we want to step back a little bit and talk, just energy codes and mechanical codes in general, because one thing that we're finding as all of this is developing in real time is that sometimes we're running into some conflicts, some conflicting recommendations and requirements, right? So if you don't mind, just start a little bit with, the fact that about a year ago, we had a new energy code that came out and kind of the impact of that.
Sure. Yeah. So when you talk about the energy code and you talk about ventilation standards, most of them are published by ASHRAE, which is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And they have a global organization that publishes these standards that are adopted as local codes. The 90.1 standard, which is the energy code, gets updated every 3 years. And about a year ago, the code cycle was up and New Jersey adopted the 2016 version of 90.1. So that is one thing where we're trying to drive the amount of energy used by HVAC systems, lighting systems, power systems, and building envelopes down in buildings just to save energy. And then they also publish guidelines and standards for ventilation. They publish a 62.1 standard, which is for indoor air quality. And that deals with how much outdoor air you bring in and how to ventilate different spaces. New Jersey is a little awkward in the sense we don't adopt 62.1. We have the International Mechanical Code that through excerpts, they kind of incorporate some of that into code. And the energy standard has you required to reset your outdoor air. So you're bringing in less outdoor air when there's less people in the room. You monitor it with carbon dioxide, which is a proxy for how many people are in the room. So you can reduce that ventilation air in order to save energy, and you're required to by code. And as you do that, you're reducing the dilution of anything in the room, and you're reducing how much outdoor air you're bringing in. And there's a lot of conflicting things when we're talking about the ventilation standard and we're talking about the energy standard. ASHRAE comes up with a way to mate them and say you can do different things, but with this COVID issue and the pandemic we're in, it's kind of come to a head where something's got to give.
Right. So, the codes and the adopted standards are really trying to kind of make sure that we're not over ventilating spaces, right? And really trying to make sure that we're focusing on the energy consumption and bringing that down. But now we're in a pandemic, and there are a lot of recommendations, as you know, about increasing that ventilation, really trying to just get that air exchange, because it's important to try to get those potential viral aerosols out of the air, right?
Yeah, so very early on, ASHRAE had published a position document on infectious aerosols and just airborne pathogens in general. And they have this data from, because it's a global organization, this data from the first SARS epidemic, they had the MERS epidemic. So they've got data and ways to try to resolve some of the issues. So one of the first things that they recommend is to increase the amount of ventilation air that you have, either one, to the ASHRAE recommended guidelines, so get it to the current standard. And then they say if your equipment can handle it, go beyond that. They also say to disable the demand control ventilation, which, as we pointed out, the energy code is saying you need to have. So they're recommending that you temporarily disable that. And they even made a recommendation where if you have an economizer, which can open up to 100% outdoor air, that as long as it's comfortable in the spaces, that you should potentially be purging the space with 100% outside air as much as possible, and stretch out those comfort, temperature, and humidity conditions a little bit, which is a little bit different than one of their other recommendations. So yeah, they had a focus on diluting whatever contaminants were in the space by bringing in more ventilation air.
Which I can imagine, actually, runs the risk of kind of straining some of the systems, right? I mean, if
Yeah,
we hear these stories about, hey, let's just open up the windows, let's, custodians being instructed to just open up the outside air dampers to bring in a bunch of outdoor air, but the mechanical systems are still set to try to cool all of that air or heat all of that air. And so suddenly you're increasing the demand on those units, right?
Yeah, definitely. And if you have a hot water system with hot water coils, there's a potential that you're going to freeze those coils because you've overridden the safeties that prevent it from freezing. On cooling systems, there's a chance that you're not going to be able to cool sufficiently or dehumidify sufficiently. So now you're getting really awkward temperature and humidity in the spaces where it could be extremely high humidity, it could be relatively warm. And if you open the windows now you're introducing outdoor air potentially. It depends on which way the wind's blowing. It depends on the buoyant effect of the temperature outside versus temperature inside. But now you potentially have outdoor air coming in that's not being heated, not being cooled, not being filtered, and just coming into the space. And now you have humid air potentially condensing on surfaces and a whole other host of issues if you're not.
Which leads us to potential conditions like we had a couple of years ago in schools in the summer, and the big M word that nobody likes to talk about in schools, right? So, this idea that it's not just a matter of one single fix. You can't just open the windows. You can't just do the, change filters. And we'll talk about that in a minute, because there are consequences to each of these steps that you do.
Right. And especially with the humidity. And interestingly, we've always had a high end of humidity that we were trying to maintain in schools for various reasons. But because ASHRAE has read articles on influenza being transmitted less in a humidity range that's between like 40 and 60% relative humidity, they're also recommending that we add humidification to rooms now, especially in the winter, because I don't know, any school that I've designed other than maybe a library, we've never even thought about adding humidification, right? So now adding humidification is a thing that ASHRAE is recommending. And, you've got to get a humidifier, you've got to get energy to make that water into steam. You've got to get, and make sure that your thermal envelope, your vapor barrier and thermal envelope is set up appropriately for the humidity that you're adding, right?
Right, because from an architect standpoint, we design walls for winter time conditions, not expecting there to be a lot of humidity, and you start to introduce that moisture, it might end up condensing inside of a wall, and then you have all sorts of potential problems. So,
right. So before you do that, you definitely need to take a look at your wall construction and see what makes the most sense. And even in mission critical facilities that we've designed in data centers or labs where we're adding humidity to those spaces, if you don't have a good vapor barrier between those spaces and other spaces that are not conditioned the same way, the moisture just pushes through everywhere, and you just are humidifying the outside, which is not something that you really do.
Right. So we touched on filtration a couple minutes ago. A lot of people are being told, just change up the filters, get a stronger filter in there, take out those contaminants, those potential particles. But again, potential consequences there. Can you talk to us a little bit about that?
Yeah, sure. The current recommendation from ASHRAE is to increase the filtration. They call it the minimum efficiency reporting value, the MERV rating. And the recommendation is to get to at least a MERV 11. To give some context, ASHRAE 62.1 15 years ago used to recommend in typical applications MERV 7. The current standard recommends MERV 8. So they arrest certain particles, the larger particles, and they do an okay job at that. get into MERV 11, that's where they first start measuring the efficiency at which they filter out particles about the size of a virus. So up, from 1 to 10, they don't have any published data or recorded data on it. It's then MERV 11 and up where you can go 12, 13, 14, 15, 16. And they have published data at the efficiency at removal of those particles. So the biggest problem is the equipment is designed to operate with a smaller filter with a smaller pressure drop. And as soon as you add a bigger filter with a bigger pressure drop, you're going to reduce the airflow that the fans can provide unless you do a full rebalancing. And that'll throw off everything. So that could throw off your outdoor air that you adjusted. That could throw off your heating ability. It could damage or destroy your cooling coils. If you slow the air down too much, the cooling coils could freeze up and damage your refrigeration systems. So there's a lot of different challenges with that it needs to be evaluated. And, you can look at the additional pressure drop of a MERV 11 or MERV 13, and then you can see, well, does it fit in your equipment? And then you can try to see, based on where the fan's operating, where it will operate once you add that pressure. And, can you rebalance it? Can you up the fan motor size, or can you change out the fan wheel? There's a couple ways that you can solve it, but it needs to be looked at holistically.
Exactly. You can't just change the filter and expect the unit to work that much harder and still last as long as you hope it will, right?
Yeah, not typical equipment that we would design for a school. That's not something that usually gets put into it. It's you can get really sophisticated equipment, but everybody already complains about me blowing their budget. So, we start designing that in there, and we're not going to be doing that for anything.
So, districts, they have either opened up at this point, or they're looking at opening up, in the very near future, with some amount of students and staff back in the schools, and a lot of pressure to make sure that ventilation rates are appropriate in a pandemic world. So, with all of this information that's going around, filters, open up air dampers, open up the windows. What do you recommend to a school district as they're trying to sort through all of this?
Yeah. So my recommendations are really based on what I've read through ASHRAE. They've got a COVID task force that's put together some really good recommendations on how to reopen different types of facilities, and public schools are one of them. So maybe we could post a link to their webpage where you could click on it, and it's got a laundry list of things to do, not just from an engineering and architectural perspective, but also from maintenance and checking, and how frequently to check the filters and how frequently to check these different things. So, I would start there if I was a school district that was looking to do that. The biggest thing that they recommend is to open up that outdoor air and to purge, the spaces before occupancy and after occupancy, and to try to have a regimented cleaning and dilution solution for that. Filtration is important, and I think it should be looked at, but you need somebody that can analyze the existing equipment and come up with a real option in order to get there, because it's not going to be a one-size-fits-all solution for anything.
So this is one thing that you and I haven't talked about specifically recently, but we've had some school district clients ask, I have all these units that are installed at different times. We might have some unit ventilators that were installed in the 60s, or have some upright units, some heat pumps that were installed in the 90s. We have a energy code and a mechanical code from 2016 at this point. Right. What are we supposed to comply with? I have people pressuring me to make sure we're up to date to the 2016 code, even 2018. But that's not necessarily the case, right?
No, the way that the state looks at it is that if you're not touching the equipment, that you don't need to upgrade that equipment. There's no mandate by the state that says you need to go in and change these things out. They have had those mandates in the past, kind of like the carbon monoxide detectors that got added to all the schools over the last few years, right?
Right.
But there's nothing that says from the state level that you need to do this. So when you do a renovation, and specifically when you replace the mechanical equipment, the New Jersey Rehabilitation Subcode kicks in, and that tells you need to follow the current ventilation standard, and it tells you need to follow the current energy standard for the equipment. So as pieces of equipment get replaced, it is when you would typically look to upgrade it to the current standards. A lot of the equipment that you mentioned, like a univentilator from the 1960s, they're probably pneumatic. They probably don't work that well. And, we've probably been recommending to replace them for 10 or 15 years. So there's challenges there. And, I was in a school 2 weeks ago in Newark where they have an air handling system from 105 years ago, and it doesn't work. And it hasn't been in operation probably in 60 years, but that's their ventilation system because they've never replaced the ventilation system.
Unless there's anything else you want to cover, I think we'll wrap it up. We appreciate you joining us today for our chat on ventilation and mechanical systems in the COVID world. And thank you for your time.
Can I ask a question?
Yeah.
What's the feeling or research that you've seen, Jeff, on those portable air scrubbers that some
yes.
districts are putting inside the rooms?
So they generally have a HEPA filter in them and will turn over the air so often. And it's actually a good idea if you don't have the ability to increase the filtration of your equipment, or you don't have any ventilation equipment. So, ASHRAE has recommended that you would purchase these. You have to size them appropriately for the room so that you get air changes that are effective. If you put, some of those sleek looking little ones that are about this, 5 inches high, you're probably not going to do much. But if you've got a nice HEPA filter that runs in the room and continuously filters that air, at the same time doesn't cause too much noise, so everybody can still hear everything that's going on, that is a good way to try to solve it. But they are noisy. I have some in my office, and we only turn it up all the way when we aren't there. So it's
some of them sound like barking dogs in the background, right?
Not nearly that annoying.
But probably not suggested to move them from room to room without cleaning the outside or anything of those to try to reduce transmission that way.
Yeah, there is sufficient evidence that the coronavirus is airborne and aerosolized. So there's conflicting studies, but it seems like there's enough that says, hey, this virus can get into the air handling system. It in a sample that was done in China where they did swabs of different areas of a hospital. It was an airborne infection isolation room. They swabbed like the windowsills, they swabbed the floors and all different things. And they did find a large quantity on the exhaust grate that was served in that room. So it does seem to be able to be moved by the air that air streams in the room. And, whether it was a live virus that could replicate, that's the thing that nobody really has that data right now because it's still emerging. So they found parts of the virus, but whether it was alive and could continue to do damage, nobody really knows.
Well, and that raises the one thing that we didn't really cover, not only the kind of in-room separate standalone scrubbers, but just any kind of in-duct or inline kind of treatment as well. We hear about all these bipolar and UV and, other systems,
Sure.
Any thoughts on those?
Yeah, based on what I've read, there are published standards and research papers that indicate ultraviolet radiation will work and it will be effective at destroying anything that's alive that is exposed at the right concentration for the right duration. So again, it's not a one size fits all. You got to look at, where you're putting it in the ductwork, how much irradiation is going to hit it, and how long or the exposure time that everything has to it. So the ultraviolet is a good effective solution. And in healthcare facilities, they've been using upper room ultraviolet solutions where above where anybody can actually see, they actually have active systems that are spraying ultraviolet at the ceiling area. So as the air turns over, it will disinfect everything in the room. So it's interesting. I was reading about that, and it could be a solution for some larger rooms like cafeterias and auditoriums if you wanted to try to implement something that had a good amount of air movement. The other technologies like dry hydrogen peroxide, needlepoint bipolar ionization, and some of these other solutions, what I've read from ASHRAE is that even though they've been around for 30 or 40 years, they're still what they consider emerging technologies, that they don't have a well-developed standard to compare them against industry-wide. If you do want to implement them though, the biggest key is to make sure that it meets the UL standard to minimize ozone production, because you don't want to generate ozone with these different systems in the rooms. So there is a UL listing, but it doesn't talk about the efficacy of, like, destroying virus or bacteria. It just is making sure that it's safe. So these systems, everybody says that they work. ASHRAE doesn't see a consistent industry standard to compare them to. So you really need to do your homework and work with your engineer and architect to make sure that that's the right solution for you.
It's interesting that you mentioned that the bipolar is actually still considered emerging technology.
Yeah, I was surprised by that too, because I have lots of salespeople pushing things like that. But
No doubt.
it seems like the ultraviolet and the HEPA filters are the tried and true solutions that have been used in healthcare facilities. And now that recommendation is going beyond just healthcare facilities, but non-healthcare facilities to try to help with the pandemic.
Well, thank you for your time, Jeff. It's good spending some time with you and talking ventilation today.
Yeah, thanks for having me. I was very excited. So this was good.